In this lab, we are measuring the absorbances of different concentrations of copper amine solutions using the spectrophotometer. Don't forget to comment, like,
and subscribe,
and give us a good grade.
Now that we've seen the lab attire and done our introductions, let's get straight into the lab. Using a transfer pipette, we fill a clean, dry cuvette with a few drops of ammonia and deionized water to make a blank.
Next, we fill a cuvette with our stock solution.
One more drop. We fill a cuvette with our dilutions from exercise 1 and repeat with all 3 of our dilutions.
When filling cuvettes, we add solution until the bottom of the meniscus is touching the line on the cuvette. Let's have a quick break and look at a cute puppy while we wait on our scientists. We go down the hall to room 360 to record the absorbances of our solutions using the spectrophotometer. Our copper amine solutions are blue. The color blue is a qualitative observation, one that describes the physical properties. The spectrophotometer makes this qualitative observation into a quantitative observation, one that can be numerically measured. The absorbance is a quantitative measurement. We open the scan feature of the spectrophotometer, clean both sides of the blank cuvette. We enter it into the spectrophotometer and then zero it. Using our most concentrated copper amine solution, we use the scan feature on the spectrophotometer to get the absorbances for all wavelengths for copper amine. We use this feature to determine a usable wavelength for copper amine and to get the absorbance chart, which is unique to the solution. Once we get our graph, we determine the wavelength with the highest absorbance to use on the Quick Reads program.
Dang, this spectrophotometer is taking kind of a long time. Next time, let's get the fast ones.
Want to hear a joke about nitrogen oxide while we wait? No? Oh, okay. We open the Quick/Simple Reads program and set the wavelength to 600 since that value showed the highest absorbance for copper amine. We blank the spectrophotometer. As you can see in this clip, we demonstrate the proper technique for the spectrophotometer. We wipe off both sides of the cuvette, placing the clean sides facing the beam and closing the spectrophotometer before we initiate the scan. After completing the scan, all results are recorded in the notebook. We repeat this process for each cuvette. Peep the proper lab attire. Woo!
The Beer-Lambert law states how molar absorptivity is proportional to the concentration of the solute. Our results support this law since our dilutions with a higher concentration have a higher absorbance. If our group had failed to properly zero the spectrophotometer, we would have inaccurate results since the spec would not properly read the absorbances of the solutions. This is the notebook where we recorded the absorbances of our solutions.
Wow, look at them actively working on their lab paper. How great of students. Extra credit? A clean lab table is the best lab table. Make sure to clean up and make an awesome environment for whoever is to come next and use the same tools. Thank you so much for watching and believing in us. This may or may not be our last video in this series. See you later.